Good day everyone, we're going to take a look at exercise 48, which is an exercise which is just after the theory that introduced trapezia. So that's what we're going to take a look at right now. They want to draw us not just a trapezium, no, an isosceles trapezium ABCD, with AB being 5 centimeter, AD equals BC, is 3 centimeters, and angle A is 60 degrees. As again, sometimes it's just easiest to start drawing with a piece of information that they give us, and I like to draw it like this, so I follow the grid spaces A and B. Remember A, B, C, D, that means counterclockwise A, B, C, and then D somewhere. Okay, how am I going to continue? Well, I know that angle A actually is 60 degrees. So I could, if I wanted to, now measure out angle A. If I do this correctly, I know it should be somewhere in that direction, right? How much is it in that direction? Well, remember, as I said, A, B, so A is connected to B is connected to C, and C is connected to D, and D back to A. And I know AD is 3 centimeters. So that now means that if I'm going to draw AD, I can follow that direction and just draw it up to 3 centimeters. Which means D must be right there. How can I now find point C? Well, remember, in an isosceles trapezium, those angles right here are going to be exactly the same, and the angle that is at D and at C as well. So I know, and I could write it down even, that angle A is going to be equal to angle B. Why? Because of an isosceles triangle. Don't have to write, not triangle, we're talking about trapezia. So a trapezium. Here. Like this. You don't have to write this down, but just so you know what I'm talking about. So both are 60 degrees. So I could now move my protractor to here, measure 60 degrees, which is in that direction, and now measure 3 centimeters, which should give us a point right there. Right? So point C must be here. And then I'm done already, right? Because now I can connect the points A, B, C, D. So this one is going to connect like this. And this one is going to connect like this, and try to do this as careful as possible. And in an isosceles triangle, this angle equals that angle as well. And if I've done this correctly, this must still be parallel to this. And as you can see, that is still the case. Those two sides have equal length as well. They already gave you that. And you see, that's what happens here as well. Okay, so do this step by step. Remember the properties of certain special quadrilaterals and use them to your advantage. Good luck.